In this presentation, we're going to look at game theory and randomized strategies and stuff like that. A particular industry always generates total profits of $1 billion a year, and it is shared between two companies, Raspberry and Robot. Every year, the companies each need to choose between two distinct business approaches: cautious and aggressive. Okay, now let's look at things from the point of view of Raspberry. Okay, so if both companies adopt the same approach in a given year, Raspberry Inc. captures 70% of the total profit, which is to say 700 million. We'll just say 700. If they choose different approaches, Robot captures 80% of the total profits. If Raspberry is cautious, okay, and 60% of the total profits if Raspberry is aggressive, okay. So you just need to parse that a little bit. So if they adopt total strategies, Robot captures 80% of total profits. If Raspberry is cautious, that means Robot is taking an aggressive strategy, okay, and is getting 800 million, leaving 200 million for Raspberry. And on the other hand, Raspberry is aggressive, so that means Robot is cautious, okay, and that means that Robot gets 600 million, leaving 400 for Raspberry. Okay, there's a lot to unpack in that particular clause there. Okay, anyway, so neither company knows what the other company is going to do in advance. Okay, that's fine. So explain why the above can be thought of as a zero-sum two-person game. Okay, it's not actually immediately clear that that's the case. But because total profits are fixed, okay, whatever one company does means that the other company can't do it. So, like, if one company wins, the other company loses. There's just a fixed amount that they can win. Okay, so that's why it's fixed. So in that case, it's a zero sum. That it can be thought of as a zero sum. Okay. The second question is, Raspberry Inc. decides to adopt a randomized strategy in setting its approaches each year. Explain what is meant by a randomized strategy. So a randomized strategy is where a player randomly chooses between different strategies rather than adopting a fixed approach. Okay, it always keeps the other player guessing. Okay, so it will sort of fix a certain proportion, a percentage of times where it will adopt one strategy and a certain proportion of times where it will adopt other strategies. Okay. Now, the third question here is, determine Raspberry Inc.'s optimal randomized strategy. Okay. Now, there's a sort of approach to doing this. So this is a sort of statement of the table. Okay, and it's the earnings from the point of view of Raspberry Inc. under all of the possible strategies. Okay, so it's essentially an expression of what I called out there previously. If they have the same strategy, Raspberry gets 700 million, and if they have opposing strategies, Raspberry will get 200 million if it's cautious, where Robot is aggressive. Sorry, just to be clear, this is Robot's strategies down here. And this is Raspberry. Okay. Where if Raspberry is aggressive, whereas Robot is cautious, it will get 400 million. Okay. Now, in order to determine the optimal strategy, we need to equate the payoffs. Okay. So what we're going to do here is just to sort of state this, that we're going to sort of assign the probability of P to a cautious approach for Raspberry and 1 minus P for an aggressive approach. Okay? Now, so essentially what we have to do here is calculate the expected value of this and the expected value of this. remember it's sort of essentially random variables, discrete random variables, and let them equal each other. Okay, the optimal strategy is, that's how you do it essentially. Okay, it's where you can't do any better than this on average. Okay, my pen slipped. Okay, so expected value if the expected value if robot is cautious is 700p plus 400 times 1 minus p. Okay, and that is equal to the expected value if robot is aggressive, 200p plus 700 times 1 minus p. So that is, working that out, we should simplify that to 800p is equal to 300, which is to say that p is 3/8. So that's to say it should take a cautious strategy 3/8 of the time, and then an aggressive strategy 5/8 of the time. And you can work out the expected earnings per year on average on an ongoing basis based on that. Okay, it would be 3/8 times 700 plus 400 times 5/8. Okay, so that's it. Essentially, that's the key thing there. How to do it? Find the optimal randomized strategy is equating the payoffs under the expected values of the payoffs under both of the other players' possible strategies that they might employ. Okay, that's it. Straightforward enough.